Can a Ruroc helmet take a direct hit? Let's find out. Let's talk about the basics of safety. Helmets shouldn't rebound energy on impact, they should manage it. A hard outer shell will spread or dissipate the energy, and the EPS liner inside will absorb or decelerate the energy. This will take the impact away from your head inside. We call this linear impact protection. If your helmet cracks or dents in a crash, that's the plan. It's a sacrificial layer. Damage to your helmet means less damage to your head. Inside every good helmet, there's a hard outer shell and a crushable EPS layer. Let's talk about that hard outer shell first. In our EOS helmets, we have a quad matrix composite construction, which gives you a good balance of weight, but most importantly, protection. First up is fiberglass. This is less stiff and rigid than carbon, but it's used to give much needed flex to the outer shell. Next is nylon fiber. It's got great elasticity, but it's strong and durable, and it has great abrasion resistance, which means protection for you against any slides. And Kevlar. You know this stuff. It's the same material that's used in bulletproof vests, and as you might have guessed, it's really good for impact protection. And last but not least is carbon fiber, the perfect blend of stiffness combined with tensile and compressive strength. Combined, this unique construction spreads the energy over a wider surface area rather than into a focus point. Think of this as your first line of defense for your head. Now let's talk about the EPS lining, or the expanded polystyrene. Now, this material can be found in most motorcycle helmets on the market, and that's because it's lightweight, it's really moldable, and it's incredibly good at absorbing impacts. We do things a little differently with the EOS. We actually have 6 interlocking sections of the EPS, and this allows us to fine-tune the density of the foam in different areas on the helmet. Once EPS is compressed, it will not return to its original form. It's a one-time thing. This is why we need to replace our helmets when it's dropped or damaged. But Ruroc has something else up their sleeve, or in the headliners to be precise. It's called RHEON. It's an energy-absorbing super polymer with 2 incredible properties. It can absorb linear impacts, like we have just covered, but it can also deal with rotational impacts. Rotational impacts can cause the brain to twist and shear within inside the skull, and that can cause concussions and even severe brain injuries. It's underrated and often not talked about enough, but thanks to the honeycomb cell structure of the RHEON in our headliner, the energy from an impact can compress and turn at the same time, reducing the risk of a severe brain injury. Rion was founded in the UK, much like Ruroc, but you'll only find this technology in our motorcycle helmets. That being said, you will find it in NFL helmets, who are really hot on concussion, and you'll also find it in Harley-Davidson jackets. So what does impact mean in the real world? Well, there's direct impact, like if you were to have a collision with a vehicle or the tarmac. There's also an abrasive impact if you were to slide out in a corner, say. And there's also debris impact. So if you were to be hit by a rock on a highway or a motorway at high speeds, then that will have an impact too. So to simulate that last one, we're actually on our way to the local golf course, and the course pros are going to be whacking some golf balls at our helmets to simulate what one of those impacts will look like. Don't worry, we'll have some science a bit later. So as you can see, the shell has done its job. It's taken the brunt of the impact and spread that energy over a wider surface area. And then the EPS liner on the inside has absorbed that energy, which would have protected your cheek had it been in the helmet. So let's talk about the testing process for ECE 2206, because this is legally required to sell helmets in Europe, but it's also a more rigorous testing system than DOT. We test all of our helmets to ECE 2206 standard in-house before they go out for independent verification. That means multiple tests with various anvils at different speeds. So this is the flat anvil, and its primary purpose is to measure the helmet's ability to take a direct impact. This is the oblique anvil. It will simulate hitting road surfaces or objects at an angle, but it will also introduce significant rotational acceleration to a helmet test. And it's really heavy. This is the hemispherical anvil and the curb anvil, also known as the curved anvil or the curbstones. And these will simulate impacts against rounded objects, like for example, the curb at the side of a road. All of these different tests provide a more comprehensive understanding of a helmet's protective capabilities in a wider range of real-world crash scenarios. So, can Ruroc helmets take a direct hit? Yes, they can. But remember that they're not designed to protect themselves, they're designed to protect you. Anyway, that's enough for this episode. If you have any questions, then please let me know down in the comments below. And if you want to nerd out about more safety testing, then check out the links in our description.